Hey everybody, let's stop that camera from shaking. There we go. Purpose of this video is to get you some solutions to the normal distribution quiz about the airline seats and the bell curve distribution of hip widths, which apparently, according to my little military website here, have an average 14.4 inches and a standard deviation of 1 inch. And as long as you know that, we can get everything else we need. Okay, so the first one is Northwest Airlines. They have seats that are 17 inches wide. We're going to define comfortably fitting as at least half an inch or half an inch of space. I guess at least half an inch of space on either side of hips. What percent of American females will fit comfortably into the seats? Okay, so here's number one. So we know, according to these statistics, that we've got an average of 14.4 inches right here in the middle. Okay, we know that for a fact. With a standard deviation of 1 inch, you know that this goes out to 15.1 inches, and this goes up further to 16.1 inches, and then we can also get down, I'm at the wrong number, 15.4, 16.4. So we're going up by 1, and then we can come down 13.4, 12.4, and we know that there are percentages that correspond to all these ranges. But our job isn't to necessarily analyze the standard deviations, is to see what percent of females are going to fit comfortably. By definition, they need to have half an inch on either side. The largest hips that can fit comfortably are going to be 16 inches wide, right? Half an inch on either side, 16 plus a half, 17 inches. So that gives us an upper limit of about 16 inches. Boom. That's the largest possible set of hips that'll fit comfortably. Everybody below them will also fit comfortably. Everybody below is also going to fit comfortably. So your job is to figure out what that area is right there. So you know that if it came up to here, you'd have 68 plus about 13. What if it comes up to 16? You can do the divisions up yourself. I'm going to use the program I gave you guys. Just a normal. We need to run a forwards problem. It is definitely left. And the right bound here, we can change it to a z-score, which probably makes sense to get it onto the axis that we need to bring this guy down here. It's z equals 16 inches minus the average of 14.4 inches, all divided by 1 inch, which removes the unit, which is nice. It ends up being, what is that, 1.6. 1.6 standard deviations away. That's your bound, 1.6. It's going to shade it for me, and it's going to tell me that I can fit roughly 94.5% of adult American females comfortably. If you're interested, the reason we're using females and not males is on average, females have wider hips, which actually surprised me a little bit. I thought it would be the other way around, but anyway, if you can fit a female, you can fit the average male too. So, cool? 94.5. Okay, now, we have a nature.com article talking about the enlargement of Americans, and we're going to assume we've got an inch wider in 2050, and we're going to run the same problem. We're going to run the exact same problem, but we're going to see what happens if the number of inches goes up to 15.4 inches versus 14.4 inches. So, we run this guy over here. 15.4 inches in the middle right there. Okay, now, the seats are still 17 inches wide. I mean, that's point blank. The seats are still 17 inches wide, which means the maximum hip breadth is still, 16 inches. So that means, remember the standard deviation being 1 again, this goes up to 16.4, which means our new max is here, which is much closer to average, which means your percentage is going to be knocked down. Now, hopefully you can understand that this is still going to be 16 minus the new average of 15.4. So this is going to be a z-score of 0.6. So you're only 0.6 of a standard deviation out versus 1.6 standard deviations out. Hopefully you saw how I got that. That was just the value 16 inches minus the new average of 15.4 inches and assuming the same standard deviation. 1 inch. Using the normal again to do another left problem, 0.6. We pick up the 50% plus a little more, we end up getting right around 73%. So that's not going to work. We're only going to fit 3 out of every 4 people comfortably. Where over here we fit roughly 19 out of 20 comfortably. So then the question becomes, all right, we've got to deal with these new numbers, right? We've got to deal with these new numbers. How wide should the seats be to accommodate, what did I say? 99.9% of adult American females. I want to accommodate 99.9. I want to make sure I get 999 out of 1,000 of them seated comfortably. And the idea, of course, is making sure that we've got the extra inch of space. So what I got to think about this is, okay, I got to figure out what the 99.9th percentile of hips is for 2050, and then add a ½ inch to both sides to make it comfy. So I'm going to start this with a picture again. Hopefully you realize this is a backwards problem. We're using the parameters from 2050 now, so 15.4 is in the middle. I clearly don't want to build the seat down here. I want to build it up here. Pretend it's a bell curve too. Apologies. So somewhere up here is going to be a shaded area equivalent to 0.999 or 99.9%. My job is to figure out what this value is right here. I'm going to start by finding its z-score, which the normal will give me. Backwards problem, you have the area, need the z-score. Forwards problem, you have the z-score, need the area. So I'm going to run more probs. A backwards problem, I'm shading to the left. 0.999. How many standard deviations do I have to go? It's going to be out there pretty far. 1, 2, 3. Just past 3. 3.09 standard deviations. So all we've got to do is figure out what is that 3.09 standard deviations. Well, thankfully, the number of the standard deviation is 1 inch. So 3.09 standard deviations is 3.09 inches. So here, this guy right here is 15.4 inches plus an additional 3.09 inches. So this guy right here is 15.4 inches plus 3.09 inches. Put the unit in there. So that gives me what? 18.49. Let's just call that 18 and a half. 18 and a half inches. 18 and a half inches is the 99.9th percentile. And to make it comfortable, you got to put a ½ inch on this side and a ½ inch on that side. That makes the seats 19 and a half inches. That will seat 99.9% of your adult American females comfortably in 2050, assuming these parameters. You got to realize a couple things here. Number one, we are putting a lot of faith in that 15.4 and that 1 inch. And that's what we talked about in class 2, is that you do put a lot of faith in your parameters that are given to you. That's number one. Number two, you have to believe that the air traffic companies, the airline companies will actually do something like this. They'll actually make the structural changes. They're going to give up, let's see, it's 17 right now, right? And they're going to go to 19 and a half, which picks up 2.5 inches times 3, which is, what is that? That's all. That's like a little over ½ a foot on both sides, so a foot total of room in an airplane to give up. It's already pretty tight, right? So it's probably going to be a design from the plane up kind of thing, or take some seats out, which they'd never do because they wouldn't make money that way. Anyway, that gets into an economics class. We can talk to the econ teachers about that. But this is just how to actually look at it from a percentage point of view based on parameter values that you know. Hope that helped. See you in class.